of the Data-Driven EnviroLab, which is an interdisciplinary research group that innovates and applies quantitative approaches to pressing environmental issues. And by the way, both VJ and Angel here, we're so lucky to have them because they're really experts in this space. VJ Gattapalli is a member of the senior staff in the Lincoln Lab, Supercomputing Center at MIT. I hope I'm getting this right. In this role, he works closely with MIT Computer Science and the Artificial Intelligence Laboratory. His research interests include high-performance computing, applications in AI, machine learning, graph algorithms, and data management. He's also founded 2 companies because, of course, that's what you do in your spare time. Radium Cloud, an AI platform, as well as Bay Compute, which is an agentic operating system for data centers. So we're going to hear about that. So just really pleased to be able to start a discussion today and hope this is interactive about what's such a critical issue. And I think we've all seen the opportunities that AI can present. And the question today is really, how do we give our students the technical training they need, utilizing AI as a new tool in the space, but also be mindful of trying to drive towards a sustainable future. So I'm going to hand it to Angel and then VJ just for some opening statements to set the stage.
Thank you so much, Becky, and thanks everyone for choosing our panel. I just got to South by Southwest yesterday, and this is my first time participating at the EDU event. And what really struck me going to different panels is that everyone was talking about AI, but they weren't clearly defining what AI is. And so I have this diagram here that shows that artificial intelligence is a really broad umbrella for a number of different algorithmic approaches and different technologies, and they are not all the same. And so back when I was studying data science in my PhD, we talked about AI's machine learning, so pattern recognition and prediction. And then that has extended to deep learning, which is like using convolutional neural networks to do more complex reasoning tasks. And I think what most of the speakers were talking about here is generative AI, so the use of large language models to develop these chatbots that we all know about, Gemini, Claude, and GPT. And so I'm going to focus most of my remarks on the generative AI component because a couple years ago, when I used to tell my data science students about AI and machine learning, their eyes would glaze over. They had no idea what I was talking about. But then fast forward to January 2023, and now I don't even have to explain what AI is because every student has had some kind of interaction with ChatGPT. And what really worries me is the fact that this was a Pew survey, and that yellow box here in the right-hand corner shows that Americans surveyed say that they're now using ChatGPT for specific information. So they're using these tools as a chatbot or as a Google to then actually acquire information and basic facts. And that's potentially worrisome because these tools do not claim to necessarily be purveyors of truth. In fact, it's the opposite. There's a huge disclaimer on ChatGPT that says there's a high propensity of this tool to hallucinate and to generate false information. So what happens in our university and academic settings when students are using ChatGPT as a first stop to help with their term papers, to help research? I think that's potentially worrisome. I always tell my students that when I went to college, there wasn't any Google, and that always blows their mind. They're like, how did you do school without Google? But I think in the next few years, the students are going to be looking at it saying, what is Google? Because I think they're all going to be using ChatGPT as the #1 place to get information. So I think this is really shifting the paradigm of education, but then also there are enormous energy and climate impacts associated with that. So we have to think through what are the different trade-offs associated with accelerating our use of these tools in educational settings while also trying to manage the climate and energy trade-offs. And so this may be a little bit hard to see, but I think this triangle here illustrates what some of the knowns and some of the unknowns are with respect to this emergence of AI in higher education in different aspects of research. So at the bottom, the direct effects from AI operation. This is data centers, and VJ's the real expert on data centers, so he's going to dive into that. So when we use these GPT tools, or we're trying to have ChatGPT generate an image or help with a term paper, there are those I think impacts can be really well quantified. But what's less certain are these broader parts of the triangle here. So when we start to scale it and we start to really interact with these different technologies and we start to incorporate it in many different aspects of our society. I think about AI being almost like electricity. In the next couple of years, we're not even going to be thinking about this as a technology that's something disruptive. It's just going to be running in the background all the time. And so it's really those aspects here that we're just not sure about the energy impacts. And that can have huge implications. So on one hand, AI could actually help us save energy by making different processes more efficient, the electric grid more efficient, for example, or to help us conserve resources. But then there's a really well-known phenomenon known as Jevons paradox, where as technologies get more efficient, their costs then lower, there could be an unintended rebound effect where we're using these technologies even more. And so these researchers here identified these two scenarios where the rebound effects of actually increasing their usage could lead to higher energy consumption, and it could offset any savings that we actually gain. So that's a real unknown. And I think that as we're trying to wrestle with how AI can help in any domain, whether it's education or healthcare, or in my area, which is environment and climate, we have to really think about that. And what's surprising is that most Americans have no idea that AI has any type of environmental impact. So my colleagues at Vanderbilt were collaborating on this project. They surveyed 3,100 Americans about AI's environment and energy impact. More than a third of them, that's these purple bars here, had no idea that AI had any resource consumption, had any water consumption, or any type of environmental impact. So that's really worrisome because most people have no idea when they're using ChatGPT, they're interacting with these chatbots on a day-to-day basis, that it actually has an environmental cost. And so that's one of the reasons why there's been a lot of conversations. If anyone watched Sasha Lucioni, who is at OpenAI, Hugging Face, Hugging Face, she had a TED Talk in September, and she basically made this argument that we need to be going smaller. So how can we shift from using really huge billion parameter ChatGPT models to more domain-specific tools? So this is like a selection of climate-specific tools. In full disclosure, these two over here are mine. But just a highlight in terms of what some of the findings we have discovered so far is that actually the design of these tools really matters. So just because they're smaller doesn't necessarily mean that their energy footprint is going to be smaller. And that's exactly what we show here, where you can see ChatGPT on the left, and this is ChatNet Zero, which we've designed to be trained on a select number of documents and to try to hallucinate, to check a hallucination. But we have two different ways of doing that. This model here uses an agentic approach. So I'm sure you've heard a lot about AI agents being the next frontier of this kind of technology, but that can mean that it consumes a lot more energy. So even though it's 61% faster, it consumes 25 times more energy when you use an agentic approach. I'm just going to skip through and talk about the really exciting sneak preview that you're all getting to get for the first time here at South by Southwest is our climate chatbot, which is called ChatNet Zero. We've taken all these considerations into mind, and we are actually updating it with some really exciting features, including being able to tell you what the energy consumption is when you make a query. So when you're asking it questions about climate change, it actually compares the energy consumption to ChatGPT 5. And so there's a lot more details. If anyone wants to ask for more details, I can dive into it. So not only are we providing more credible, scientifically grounded responses, but actually it's more energy efficient. And I did a little bit of a back of the envelope calculation earlier today. And actually, if everyone in Scotland, so they have a population of 5 million, were to use our tool compared to ChatGPT to ask a climate-related question, we would save 1,400 kilowatt hours of electricity. So that's akin to powering someone's home for 1 or 2 months, depending on how big your home is. So that can be really tremendous. So it's these design choices and how we also use these tools that affect the overall energy footprint. And so thank you. I know that was longer than what you were expecting, but I just wanted to take advantage of this opportunity to share this.
This foundational information, and I hope you guys found that helpful. VJ.
Yeah, so thanks, Angel, for providing the groundwork. Saves me a lot of trouble. So I try to think of the computing stack where we have the actual hardware, the infrastructure where things go. So I tend to focus on that side, and that's a lot of my research. And I think, coming back to the theme of this particular panel, I think there's some huge opportunities. I think Angel did a great job of kind of outlining or laying out what some of the climate and environmental impact of AI is. And I think there's a huge job of educators to help get that message out, right? I think people are starting to understand it, but the scale and scope of this is still not well understood. I run, one of my hats is I'm the co-founder of a cloud computing company, which interestingly is where Climate GPT was trained right before COP28. Yeah, so that was on our That was on our so they're working with that team back then. But people don't understand like how much power one of these models uses. So for one of our models, they're often using somewhere between 15 to 45 kilowatts of power to run one copy of a model. Just to put that in perspective, your house is probably running at about a kilowatt, maybe 2 kilowatts. So it's like 15, 20 houses at once to run one copy of a model. And then the other piece is that this is hidden, right? We like to call it the cloud, which is great for companies like ours, which makes it seem very nice and airy and fresh, right? Clean cloud, right? However, what that's doing is hiding the emissions from people. I like to give this anecdote. When my son was learning to read, he was going through these books pretty quickly, and so I decided, hey, let me just write a little iPad app for you. And so I got his iPad. I wrote an app. It used generative AI on the back end, so he could input some ideas. It had some guardrails in place. He could talk to the iPad, say, I want a story about actually a goat eating Nutella. That was one of the stories. And it would create some nice, cute pictures, little storybook, and then he could read the book. The quality of the story was poor, so certainly not trying to say that this was great prose. However, it was good enough for a 5-year-old to look at funny pictures and a goat eating Nutella. I then did, as I started to do more research in this space, look into what each story's environmental impact was. And so this is just pressing a button. It was running on his iPad. And it turns out the amount of energy that one query was using, that one story was generating, used as much power as the entire iPad. However, the iPad wasn't getting discharged because that power was being done somewhere in a cloud, likely Virginia, or somewhere outside of the house. So my iPad was working just fine, and he would right, hit that over and over. And so I think there's a lot of this hidden cost behind this, which again, from an education perspective, gives us some huge opportunities to train the next batch of people. And I just want to end with, I often give these talks and come off as a gloom and doom person, like we're screwed, we're going to mess up the environment. We might, but I think there is a lot of hope. And one of the hope is that there is a lot of low-hanging fruit that we are not using for efficiency. And I think that's great. The other thing, I think as educators and universities and academics, we're often constrained in our ability, right? That was our research effort at MIT about 4 or 5 years ago, started because we couldn't grow our data centers. We're not a private company to go sign a lease with a big bank and sign up a gigawatt of power. As much as our user base might have loved that, right? As much as our researchers at MIT would have loved a gigawatt of computing, we can't do that. And so what we learned to do was how to do more with less. And turns out you can do a lot more with less if you're smart about it. And so I think that's another huge opportunity from the academic perspective of how do we instill efficiency and careful usage of these resources from the get-go. And if we do that, we're not only empowering our students to use AI, which is a necessary skill today, but also to be able to do so judiciously and carefully in order to balance the environmental needs with being able to move forward. So that's sort of a few thoughts from my end.
No, that's so great. And thank you guys for that starting us off. I will say from my side, my academic background is actually in toxicology and exposure to air pollution and things. And so riffing off what Vijay said, I really feel like we have an opportunity here. We've done this before. We've thought about these kinds of problems when it comes to traffic and power plants and emissions. So I remain optimistic. But to turn to you, Vijay, I think just, frankly, when we think about especially large universities and colleges and the higher ed system in the United States, AI has a lot of potential. We know students need it as they're looking to graduate. We believe, I think, across the panel that it's a key skill. But it seems like the conversation around what is an AI footprint and what should that goal be and who is positioned in higher ed to really be framing questions around AI footprint, that's just not a conversation I've heard very often. And I'm wondering how you think about that.
Yeah, I completely agree. And if I think there is a challenge that higher ed faces right now where continuing with the same path of education. I was talking to someone recently who started it's a generative AI based tool. It's actually become quite popular for teaching younger students, and it's able to personalize. And there's this, I don't know if somebody's heard of, has anyone here heard of like Alpha Learn? Is that a concept? Yeah. So I think there are a lot of these really interesting AI tools that are coming out that might actually change the way we educate. And so I think the days of, you know, coming in with a predetermined lecture and going through that, I think those days are gone. And so now the question is, how do we make our students understand concepts and understand, because even if, how many people here code using AI or use that to help write software? You know, a few. It's incredibly powerful, right? I keep telling people, I feel young again. I feel like a young grad student who knew what was happening in the world of programming. I'm able to do a lot. However, you still need the logic, right? You still need to know what you're trying to solve, how you want that interface to look. And so the question is, and so that does not, the AI could not figure that out on its own, or if it did, it would probably not be good. And so the question is, how do we instill that teaching in students in terms of understanding logic, science? I keep telling people that the fields that are going to be the hottest are things that involve social interaction. Like, I think sales is going to take off all of a sudden, right? Like people who are in technical sales, so who understand, because it's all about human interaction and relationships, which an AI cannot replicate, or not well, as much as people are trying to do that right now. The other piece is really on understanding domains. So I think general purpose AI, so this has been crazy, right? Like 5 years ago, when you would talk to people, you'd say, hey, what should I study? And it's like, learn to program. That'll get you somewhere, right? Even an average programmer will do something. And I think that is not the advice I would give today, right? So now it's like lean into domain stuff that AI does not know about, whether it's on toxicology or other specialized fields. Is how do you learn that part? And then you can use the AI to aid you in solving problems in that space, which is exciting. And then the final one is embrace the resource constraints that we have in higher education, right? It's easy to complain, but I think that also makes us extremely intelligent in coming up with new things. I'll give you a very specific example. 2 years ago, how many people here have heard of DeepSeek? Probably everyone, yeah. Nobody heard about it more than 2 years ago. And DeepSeek was able to show that, and there's a whole bunch of, I'm not going to get into all the other, I've opined on this in other venues, but they were able to create a model that performs similar to some of the frontier models at that time with a fraction of the resources needed to run it. We don't know about the training exactly, but the claim is also on the training side they were able to do that. And there's this big thing about why and how. And there was a large part of that was due to the fact that there was resource constraints put. And so that allowed them to be more clever, maybe incentivized them to be more clever about, and they made a few certain tricks that suddenly compressed the amount of power, energy, environmental footprint, cost, et cetera, that was able to do it. So I think even if we are able to take that approach from the higher ed side of, let's take these resource constraints and say that it may not be something that a commercial company is running into today. I can say, from my wearing my commercial hats, that cost savings is still not things that people are interested in, but they will be very soon because these costs are starting to pile up. Even the largest tools you use today are having difficulty showing that they're profitable. They're able to show that they can get a lot of money, but they're not able to show that they're able to make any money off of it, which is why they're all private companies. And so I think that efficiency, being able to get more out of less is going to be important skills that higher ed is probably the best suited to, because naturally we don't have the resources. And so we'll just pretend like that's part of the plan.
Yeah, and if I could just add to what Vijay said, and I agree wholeheartedly, I think for higher education, it's also establishing what those use cases are. I think the domain knowledge is absolutely critical. And what I have seen, particularly for generative AI, it's 6 to 14 times more energy intensive than other AI applications. That's just the estimate. And there's not really a clear use case for, well, what can this actually do that can solve a particular problem uniquely well? And then at the same time, how can we mitigate any type of negative externality like the energy footprint or the climate footprint? So I think that's really critical. I would also add, my lab just celebrated our 10-year anniversary. So I brought back a lot of my former students to share their insights. And one of them is a vice president at L'Oreal in data science. Another one is working for State Department. Another one is a environmental NGO. And then another one is a data scientist. And we asked them the same question about, okay, how are you seeing AI change your jobs and your workplace? And what they said, in addition to everything that you said, was also the soft skills. That's what they really want. And so I think if higher education universities can also help students to develop those skills and what one of them said, which I thought was brilliant, was red team. Like, you need to really understand how all of these different chatbots and AI systems work and their weaknesses, right? Try to really stress test them and understand the nuances, because they're not all the same. And there's some that have some advantages and others that are not as strong in other areas, and then really understanding those strengths and weaknesses, he said, is a real advantage for students. So I think a radical shift of higher ed to teach students to not be afraid, and honestly, faculty, we're also very afraid of this technology. I mean, it's completely changed how I teach data science, where of course students are going to use it to code, but then I have to interrogate. I had to completely flip the classroom and say, okay, well, all right, you're using ChatGPT. It gave you a response that is not at all what I was expecting, not at all what the pre-work trained you to do. And so explain like what it did and why. Like I think this type of interrogation and using AI as like a sparring partner, or in that sense, can be really helpful in students developing that kind of knowledge and then understanding where their domain knowledge can fit. Because exactly across the board, they were saying they're looking for people who can synthesize, who can really frame an argument really well, and who can articulate that and help identify like what are the blind spots. And so I think we need to not train students to blindly use the technology, but really to be aware of everything it can do and both its strengths and limitations.
Yeah, I love this, and we'll move on to the next question. But before we do, I just want to say, as someone who used to work in contracts for the U.S. federal government, I do think there's an opportunity here to say higher ed is a critical consumer market for these tools, and there's power there. We can ask for things to be done. We can ask for doesn't mean we'll necessarily get it, but we can ask for transparency or thoughtfulness in design. And maybe that's an opportunity to sort of drive some conversations, if not some change, around the directions market's going. Because Vijay, you're right. They're not, I mean, nobody's starting a profit right now. And the cost on these things is kind of all over the map. So just wondering, as we think about the benefits, which I think you just touched on, Angel, about using AI for education or for climate, and you sit at the intersection of those, how do we think about justifying the footprint or making sure that the use is kind of backed by good decision making? I think we touched on that a little bit, but maybe going a bit deeper.
Yeah, for me, that would involve mapping out the various value chain of AI within a higher ed system and trying to understand and making the case for where this can really add value. Mm-hmm. And I don't think that universities are that concerted or thinking that concertedly about AI. It's all like really piecemeal and ad hoc. And it seemed like when I was in panels yesterday, similarly focused on AI, that's what a lot of folks are saying. They're like, oh, you can't tell individual faculty how they can or cannot use AI in their classrooms. It's all up to them. And that's very similar, where we did our students did a survey last year at the UNC campus, and they asked students at every level and also faculty, well, what kind of guidance do you provide on AI usage in the classroom, and what kind of AI usage is acceptable use? And students universally said we want to have a lot more standardization and guidance for conditions under which we can acceptably use AI and other conditions when it's not. And so I think a lot of universities are having similar conversations, but I think that it would be really useful to bring these communities and stakeholders together in an academic setting, everyone or whatever community or organization, and say, okay, well, in what situations could AI be helpful? Where can it add value? How can we integrate this to improve our workflows? And then what are areas in which it's not helpful? Because you'll have some English composition professors who draw a hard line and say, no, I still want students to be able to articulate an argument, to structure an essay. But then for me, I'm in data science and policy. And so for me, I want students to really embrace the technology and to understand its weaknesses. So I think it's really difficult to universally articulate or mandate a policy, but that opens an opportunity for universities to really sit down and think about where does it add value. And of course, I'm going to add on in terms of the energy and the climate impacts as well, because I think with our Chat Net Zero tool, what we're trying to provide is that information, that level of transparency to consumers to say, okay, well, I can see how when I have a higher order task that has a lot more energy, and then when I have a more simple task, it's lower energy. So what kinds of tasks can I reserve my use of the tool for? And then what other tasks should I maybe not use ChatGPT for? So the slide that I skipped over, and I can't find okay, here it is. So the slide here, what we found, so last year when Sam Altman said, stop being polite to ChatGPT, it's costing us millions of dollars, that put a light bulb in my head, and I said, oh, well, does that also mean it has more energy that's being consumed? And so we tested that. And so that's what this is showing these two. It's actually not the input of your prompt, not the input length, the length of your prompt, but it's actually the output that drives the energy consumption. And so you can be as polite as you want. You can say please and thank you all you want to ChatGPT. It does not matter. It's actually the output that makes a big difference. So when we constrain the length of the output, so that's that red circle, it's actually a lot more less energy consuming than allowing GPT just to go, and they'll give you sometimes really long-winded responses. And so knowing that and then educating our students to say, yeah, you can actually save energy if you just tell ChatGPT, give me a short, succinct response in 200 words or less. You can actually save a lot more energy than just letting it go off the rails. So I think it's also important for a university to educate, to do this kind of research and to understand, like, what are the conditions under which perhaps we don't need to be using these resources, or we can guide students and faculty in terms of this type of behavior. And so I think there's two sides of the coin, like on the design and the research side. And then there's also like the everyday usage and how students are consuming and interacting with these tools.
Yeah. Can I add a? Yes. So first of all, love that. We had also done something similar where we were able to reduce carbon emissions by nearly 80% without any perceivable change to the answers, just by constraining the length. But I also wanted to add maybe one, and maybe almost a question for both of you. Like here's the maybe a paradox, right? Like to kind of use the session title. On one end, in higher ed, we're putting all sorts of restrictions on people on how to use generative AI. You can't use it to help write a paper, or you can in very limited settings, maybe to help you get your language right. But and then you have to clearly outline, and it's unclear whether that, whether a reviewer sees that and looks favorably or unfavorably upon your, it's like, I use generative AI to help me write the introduction. A reviewer might discount the introduction just sort of mentally. That's where people might be. But then people go into the commercial world and like, I really don't care. Just solve the freaking problem as fast as you can. Try to be careful on IP, but that's really about the only constraint. And so I'm wondering, given that difference, right? And I've actually found a lot more people leaving academia to go into the commercial world because they feel unconstrained. Versus, I know at MIT, if we're putting a grant proposal together, or obviously an academic article, really anything, it's sort of they're kind of like you can but don't, right? And certainly with grant proposals and things like that, you have to be extremely careful. And so there's, what people are in the commercial world taking an hour to solve, we're often artificially constraining ourselves for good reasons, because we're also trying to teach certain concepts like critical thinking and things like that. But I'm wondering where that balance is and how much of it changes, right? There was a time, I'm sure, when calculators came out that people are like, nope, you should do it by hand because it's really important that you learn how to do it. Right? How many in this room would, if I gave you a 5-digit times 5-digit number, would be able to solve that fast enough? Right? I mean, you probably know how to, and given enough time, you could. But that's, we've kind of moved on from that being a skill that we think is important. And so I'm curious on this, where is that balance? And are we too far on one end, or where do we go over there?
Yeah, it's such a great question, and I don't exactly know the answer. I think my experience in higher ed is that everybody's sort of feeling it out under the broader umbrella, which I think we've heard discussed in other sessions here at South by Southwest a little bit. Like, what's the future of higher ed in general, and is it really, like, how much are we developing, humans, which we are, versus preparing for the workforce, which is not, not mutually exclusive, but the approach is a little bit different. So yeah, I kind of think in that framework, I tend to think it's important that we do both. But I'll give you an example, and this was strictly self-serving BJ, is like before coming to UNC, I used to work for a consulting firm, and I was doing science and data science in that firm. And when I would talk to scientists, I would give them in the language I was comfortable with, all the ins and outs of what we'd done and what the conclusions were. When I talked to C-level executives, they would just glaze over. Like, it's a different language. They don't want all that detail. And I would often use something like a chat GPT to help translate into what I used to call MBA speak, because it saved me a lot of time, right? So, I mean, I think there's a practical application there that doesn't short circuit the thinking behind the idea, but we're all just experimenting, trying to figure out that balance, I believe. What do you think, Amy?
Yeah, I agree. I agree with what you said. And I do think, VJ, that we're kind of constantly wrestling with the question that you so eloquently posed. And I mean, for me as an educator, the number one thing that I want my students to be able to do, and we say it all the time, is to critically think and to be able to even criticize and be critical of these AI tools. And I think too often students are not doing that. They're shortcutting, they're using these tools to generate a term paper or to do the research but I kind of want them to develop those hard skills so that when they get to the workforce and they don't have those guardrails and they can just go crazy and use all these tools, then they can spot the issues. I mean, just as an example, I noticed in a term paper that some of the students had turned in that they came up with a wild statistic that said, and this is in my climate change class, so it was like cool pavements can reduce temperatures 36 degrees Celsius. And I was like, that is an outrageous number. And it turns out it was AI generated, or somehow, I still can't reverse engineer how they got to that number, because I looked at the citation and that number, I went to the original paper, that number was nowhere in there. So AI just hallucinated this number, gave them a citation, and they didn't even check it. So I don't think you want to hire any of those students who don't know. Like, you got to check the basic numbers. And if they are giving it to an IPCC climate scientist, which I am, like they need to really double check all of the numbers. And I don't think students are doing that. And so I've been calling them out, and even simple things like where I say, I want you to watch your fellow students' presentation, and then give some critiques. Students were using ChatGPT to generate those responses. And I had to stop them in their tracks. And I said, I can tell all of this is ChatGPT because it's all the same structure of, oh, you did a great job doing this. Overall, it was clear, accurate. And I'm like, I know you're using AI. And so I told him, I said, I'm going to take off points if I suspect you're using AI. And then I was like, I don't care what your grammar is like. This does not need to be a polished response. Just tell me your reaction. This is really important. A soft skill, or a higher order skill. This is kind of what my husband, who works at the business school at UNC, he told me to stop saying soft skill because it makes it seem like it's less of value. So he says now a lot of the business school people are saying this is a higher order skill. So I'm trying to change my vocabulary. So the higher order skill of being able to give feedback in real time, to be able to digest information, think about it, synthesize it, and give a critique in real time. And so that's what I want students to be able to do. So for me, I would put guardrails on. I would not give them unfettered use to AI, because the young people, I'm telling you, they don't know how to separate the accurate from the inaccurate from the, So we need to have them do that,
it's
so
like
that
the
when
new Turing test. If you can detect it's AI, they lose points. I like it. That's a very smart way of doing that, right? If I can detect this is AI, then you're wrong.
Yeah, and I spend a lot of time with these tools, so it's always surprising that students try to give me this AI slop. I'm like, I'm on the North Carolina Governor's AI Leadership Council for a reason. I am doing this work. Like, why? And the fact that they can't discriminate that, that's a problem.
Right. Yeah, I love that story. That's such a great point. I do want to invite anybody from the audience, if you guys have questions to pose to any of the panel, to just come on up. We're hoping this can be, don't be shy, don't be embarrassed.
Controversial questions are the best. I think this is not recorded, so.
All right, there we go. Hey, so my name is Miriam. I'm a tech founder. I help all the health allied professionals, pass their licensure exams, get a job, maintain their license. So I'm in that space. But with AI and all the craze, I'm really curious. This is more of a philosophical question, because when the internet came out, it was accessible to everybody. Now that these AIs are coming out, it is not accessible to everybody. Either you have a pay-to-play model. Maybe the government's going to have some, here's a freebie for the poor people that can't afford it. That's on a base model. I'm not sure. But I'm just really curious because it's different than the internet. Like when yeah, you had to pay for internet, but I could always go to my library. It's free, or like they had programs and stuff. But I felt like now it's not the case, and there's just a lot of competition. They're trying to fight with each other to see who becomes the best model to be used. But just really curious on that because everyone's saying, it might create a huge disparity of the haves and the haves not. Do you want to start?
Yeah, so I think that I'll kind of partly agree and partly disagree with you. I think there's some baseline access that's now readily available to a lot of people. But I do agree, just given the current cost models, it's really difficult to sustain running free, right? It's being used for like grabbing customers, and then there's a bait and switch on them because it costs a lot. I mean, if you think about it, not a lot of people realize this, but to run one copy of the model, right? Like one of these, like a DeepSeek, for example, it's about $500,000 worth of computing equipment that you need, plus a bunch of peripheral. It's not even the electricity cost that's bothering anyone right now. It is the cost of the equipment. GTC, which is NVIDIA's big conference, is next week. And this is where they're going to tell us about how the next thing costs even more money. And so just the current cost economics are so wonky that it's very difficult. Even if the government wanted to, I mean, people are spending hundreds of billions of dollars to build the infrastructure, and I hope the government is able to participate. And I think even if it's not the U.S. government, I think there are international governments that are looking at making this happen, but it's still the cost of the equipment's really high. Now, that being said, that's today's problem. I do think that looking forward, things are actually a lot rosier, right? Like things are actually going to get better for two reasons. One, efficiency. People are understanding that efficiency is key. And I'm not trying to pitch a company or anything like that, but on my second company, which we recently started, we're able to show that like in a data center, we can shave 30-40% of the power like that just by being smarter with how you use your power, which means that translates to smaller costs. And so and we're just one of the players in this field. There's dozens of other people that are doing even more interesting and exciting things. And so I think we're maybe it's not an immediate thing, but in a couple of years, I think we'll start to see that balance or that gap start to shrink a little bit, where the top line, we're starting to hit essentially the limits to a certain extent in just general domains of where this is going to be, but we're seeing that the bottom side is starting to come up. So I think that's a good sign. And then the nice thing about it is built on top of the internet. So whether you're in a developing nation, I mean, we work with children across the world, and people in India are able to use these. You need a cell phone and a data plan, and you're able to get, whether it's high quality lecture material, AI generated notes, things that can translate into your native language. I mean, these are all pretty cool things. So I do agree with the sentiment, but I am also fairly optimistic that, because the top is sort of reached, it's like you've hit the highest performance car, and then now all the other cars are starting to catch up. There's new hardware, there's efficiency technologies, models are getting smaller. Folks like Angel, they're figuring out how to compress models and get the same quality, which I think is really exciting.
Okay, thank you. Not to hog this, in case you guys come up and speak. So another controversial question, which everyone's talking about, is how the fear of AI is going to take away knowledge workers, because essentially, you can get whatever knowledge you want from AI, right? Why should you hire a consultant or educator or whoever, XYZ? So just curious thoughts there, just because that is top of mind for a lot of people. I know they talk about universal basic income, but how is that going to work out? So all these questions in that space.
Yeah, that's a really big question. And if I had the answer to that, I think I would be a very rich woman because then I could solve all these problems. But I will say, so I mentioned that I'm on the North Carolina Governor's Council for AI Leadership. And so it's 25 people across the state of North Carolina. And we're tasked with developing a roadmap on responsible AI usage. So how can we accelerate AI across different sectors, from workforce development, education, K-12, and then higher ed, infrastructure, and attract businesses to also accelerate the economy. And so I think this is a really interesting model that other states could also adopt, and to think about, okay, how do we ensure that we don't have a huge impact in jobs? And one of the things that they're doing right now is a statewide assessment in terms of trying to actually be more specific, because I think there is a lot of fear mongering and people are like, oh, AI is going to destroy everything and it's going to, but actually that's not the case, right? Like I think, what was it, Anthropic just released their study where they showed, there's some sectors that are going to be more impacted than others. And so I think it's generally unhelpful to just fear monger and say, oh my God, it's going to take away, because actually I think it's going to create a lot of jobs and a lot of opportunities in some areas. But I think being really sharp about what exactly those sectors are and what sectors. So yeah, like a lot of trades, I think that came out of that study. So obviously construction and plumbing and these sales, exactly. These are not going to go away. But then, like a lot of the consulting jobs and like they're, I think, more vulnerable. And
as a former consultant, I find it okay. Like in many roles, I think my best skill as a consultant was actually in hearing somebody describe a problem and distilling it to what their problem actually was, because it's almost never what they tell you to start. And I don't think that's a skill that AI can substitute for.
It's a higher order skill.
It's a higher order skill. I do have them, but yet, I mean, definitely, will that reduce the amount of research that's needed to execute a solution? Possibly. But what I love about being in education, and I don't think this just applies to higher ed, I think it goes all the way down to K-12, is this is an area where we should be focused on the entire population and what it means to enable and bring those voices to the table. Not all sectors have that benefit, opportunity. And so, maybe South by Southwest EDU is a place to kind of pose, what can we do to get some of these other voices at the table? Because right now, I think everybody seems like we're caught in a bit of a reactive moment, when in fact, we could be much more proactive about this. I mean, we have the power of our purse. That counts for a lot. I don't know what you think about that, BJ.
Yeah, I completely agree. The power of the purse is going to be quite important. I helped lead a initiative. There's this organization called the Open Compute Project. So it's a nonprofit organization that a lot of big computing companies are a member of. And I helped lead one of their sustainability efforts a few years ago. And we were looking at, from the sustainability side, we often talk about the energy costs of AI, and we think of that, that's the operational footprint. There's this other footprint that we don't often talk about, which is what we call the embodied footprint, which is, hey, somebody had to make that chip, and it probably used a ton of energy and chemicals and had some environmental impact to actually manufacture the chip, to put the concrete into a data center, to put the air conditioning equipment. There's a whole hidden side of, right? So a lot of the push in the public has been, let's do renewable energy. That's a good step. It helps reduce the operational footprint, but it doesn't yet do much for the embodied footprint. So this is a group of people that we're getting together to try to essentially put together, almost like you have the nutrition guide. We wanted to put something similar together, but on the embodied footprint. The OCP is a fairly large, established organization. One of the first things we saw is that the hardware manufacturers are quite reluctant to provide that information. And so the strategy that we took was to actually get their largest consumers to be on this organization. So you had your hyperscalers, your Microsofts, your Googles, and that was able to help drive change because they are the customers. And generally a company, if the customer asks, so coming back to the power of the purse, people are far more open because it's all the customers asking for it, versus, the academic me, it'd be wonderful if we had this. I'm like, yeah, I don't care. Are you going to pay me for that? But it was actually very helpful. So I think where there's an opportunity for higher education, individually, we're all pretty small customers in the scheme of things, but collectively, we're actually fairly large. We have lots of users. We can help influence decisions because our students go on to lead, like the State Department or other organizations. And so our training that we give can actually permeate. It does take time, as with most things in higher education, but I think getting the right thinking can actually, if we start to, I know MIT loves to do these thought exercises. Oh, if all the MIT companies were put together, we would be, 7th largest economy in the world. One can argue with that particular stat all they want, but it's fair to say that if you took all the MIT alumni that have gone out to start, lead, run businesses, there is a fairly large impact with that. and it's true of every major university. And so I think that's the opportunity, that we can start to get people to think in the right direction. And as they make their way out and have these massive, tremendous careers, that thought process is changing the way that major companies operate. And then you start to see change happening. It'll take a while to start off with, and then it'll start to speed up very quickly as there's sort of critical mass and consensus.
So I realize we're headed towards the end of time. Does somebody have a question? If you want to come up and close us out.
Yeah.
Yeah, we can hear you. I'll okay. I was going to repeat it, but
very useful information. Thank you so much. I work with the folks that are in the environmental sector, and sustainability is a big thing, and it always comes up as a controversy of me using AI to do the things that I do, but you're not being sustainable, and that's what we're here for. So, like, what would your advice be to give to those folks? You've already given a lot of it today of, like, there's some low-hanging fruit, and AI is working on the problems of AI. But what would you say to those folks that are concerned about the sustainability? And what would you say to those folks that are doing research, mainly in plants is where my field lies? But how would you even encourage them to use AI? Because I always say AI is your very ambitious junior associate that wants to tell you the answers, but it will also tell you the wrong answers because it wants to please you. So how do you frame those prompts so that you tell it the right thing? So,
I mean, you really hit so many really amazing nails on the head. So on your first question, I think that we need to, as consumers, demand these big companies, because as Vijay was saying, they're not transparent at all. And so Google came out with a report saying, oh, one little Gemini prompt is only 5 teeny drops of water. And it's like, yeah, but how many prompts are happening? You're talking about billions of prompts. So it's not just 5 tiny drops of water. So I think we need to demand that transparency, because that information is really hard to get, is what we found. And so I think that's the number one step. And then I think holding these companies to account. So I think we've been talking a lot about procurement and the power and the agency of the purse. And I think that's really important. I'm trying to speed along. And then your last piece about prompting and prompt engineering, it's so on point. And so that's a project I'm working on right now. So we're actually helping, so it's under NDA, but if you think about the largest company in the world that has, I mean, more money than country's GDP. So I'm advising them and helping them develop AI workflows for credible decarbonization playbooks. And that's exactly something as a society we're now grappling with. How can we prompt in a way that gets more accurate answers, that reduces the hallucination, and can actually lower the footprint? So that is coming. So feel free to follow up with me afterwards.
I'll end very quickly. I think one of the biggest hopes I have is, for the first time, climate change, AI, and economics are all aligned with each other. So we've done presentations, you can guess for whom these presentations are for, where we've been able to remove the word carbon and replace with energy, replace with dollar signs, and the plot still holds. That's awesome. You don't have, if we're running things more efficiently, that means that people can make more money off of it. That's actually great. It's not like we're telling them, oh, you have to put $100 million worth of solar panels for this to pay off. But we're just telling them, hey, be more clever with the way you run your models, run your technology, and you're better off. So I think that's what gives me the most hope, that it actually makes economic sense and commercial sense for people to do it. So I think we'll get there. Right now, the incentive hasn't been there yet, but I think we're getting to that step very quickly.
Thank you guys so much for coming. Feel free to catch us after if you have specific questions we didn't get to, but really appreciate the conversation.
Thank you.